Part H of question 3 is asking us to solve for the length of AB, which is this chord here. And so looking at this question, we can see what we have is we have one line that goes through the center of the circle here, and it's crossing this other line here, and it's perpendicular to it, which is given by this right angle here. That means that all these other angles are also right angles, and these two lines are perpendicular. And because this line goes through the center of the circle as well, this means that this line here is being bisected. So that means that this, the length of this line is equal to the length of this line. And we've been told that the length of this segment is 12. So that means that this segment is also 12. And now we have a right angle triangle with one side 12, one side 15. We can find this other side here just using the Pythagorean theorem. And so that's going to be, I'm going to call this short side x. So I'm going to say that x squared plus 12 squared equals 15 squared. Okay, so 12 squared is 144. 15 squared is 225. Subtracting 144 from 225 gives us 81. We take the square root of both sides, we get x is equal to 9. So this segment here is 9. And now what we want to see is that we have two lines, or three lines really, coming from the center of the circle. This one here, here, and here. And those are all the radius of the circle, so they're all the same length. We know that this radius is 15, given by this. So that means that this length here, from the center of the circle to B, is also 15. We know that x is 9, so we can say that this length up here is equal to 15 minus x, or 15 minus 6, 15 minus 9 is equal to 6. So this side here is 6. And so now, again, we have a right angle triangle where one side's 6, one side's 12, and one side's unknown. We can figure this out through Pythagoras' theorem. So in this case, we have 12 squared plus 6 squared equals side AB squared, which is what we're trying to find. 12 squared is 144. 6 squared is 36. And when we add those together, we get 180. So now taking the square root of both sides, square root of 180 is going to be a decimal. So I'm going to rewrite this, just flip this around, get AB segment is equal to the square root of 180, which is equal to, sorry, those should be squiggly lines, about 13.4 when we round. So our answer here is that AB, we'll just round to one decimal place, is equal to 13.4. In part I, we have a similar situation where we have this line here, and it's perpendicular to this line that goes to the center of the circle. So again, we are bisecting this line, and these two sides, or these two lengths, are equal to each other. But we've also been told that these two lengths are equal to each other. So in this case, we know that this side is also 6, because these two are equal. And we can come up with a triangle here that's also a right triangle, with one side that's the length OA, which is what we're trying to find. And so we can come up with another equation here using the Pythagorean theorem, where we know one side is 6, but we don't know the other two sides. But actually we can figure out an expression for this side, because we know that if this is OA, this is the radius of the circle, this is also the radius of the circle. And so because these two are split into equal lengths, this one side here we can express as 1/2 of OA, or 1/2 of the radius. And so now we can come up with an equation with only one variable, and that is 1/2 times OA squared plus 6 squared equals the hypotenuse, or OA squared. So I'm going to square this 1/2 here. So 1 squared is 1, 2 squared is 4. So this gives me 1/4 times OA squared. 6 squared is 36. And I have an OA squared here. And now I can combine like terms. I'm going to subtract 1/4 OA squared. Sorry, that should be a 4. From both sides of my equation. And moving up here, those are going to cancel out, and I'm left with 36 on the left side of my equation. 1 OA squared minus 1/4 OA squared is 3/4 OA squared. So to get rid of this fraction, I'm going to multiply both sides of my equation by the reciprocal, 4/3. And so on this side, those are going to cancel out, and I'm left with just OA squared. On this side, 36 times 4 divided by 3 ends up being 48. And now I just have to take the square root of both sides of my equation, and I have OA is equal to the square root of 48. I'm going to write this on this side. It's equal to the square root of 48, which when we round is about equal to 6.9. So you can say that OA, if you round to one decimal point, is equal to 6.9.